My name is Hugh McKee, and this talk is from Stateless Serverful to Stateful Serverless. So in the talk, I'm going to be covering that. I'm a developer advocate at a company called Lightbend. You may have heard of Scala, the programming language. Lightbend is the company behind Scala, as well as Akka, which is a toolkit for building distributed systems using the actor model. But in this case, what I'm going to be talking about is kind of stateless and stateful, and also spending quite a bit of time going into some code. And really what I want to introduce to you as the main theme of this talk is, because this is an event sourcing conference, is serverless event sourcing, basically. Serverless event sourcing, serverless Cqrs. And that's what I'll be working towards after we go through a bit about stateful versus stateless. So that's really the contrast here is, stateless and stateful. And the main thing is that with serverless, you always hear, oh, yeah, there's serverless, but of course there are servers. And it's the same thing with state, that the very common model for us to build backend systems has been the stateless approach. It's part of the 12-factor app, all those kinds of things. And it's been something we've actually been doing for decades, building these stateless kinds of backend applications. And it's a model that works really well. But with stateless, there's still state. The thing is that you can think of backend systems really as state management systems. What we're doing is we're getting requests in to perform some kind of operation, which is a state changing operation, one way to think about it. And then we're persisting those state changing operations. So backend systems are these state management systems. So what's the difference between stateless and stateful? And that's what I want to walk through here, is kind of just a contrast the two. Both are great patterns, and I'm not going to say one's better than the other, but there definitely are. There is a difference, and that's what I want to show. So the nice thing about stateless is that, and hopefully you can see this animation. It's a little animation here, but I'm just having some fun instead of static pictures. But the idea is that we have one node, and it's got some traffic, and these little dots just represent requests that are coming in. And we're performing some kind of an operation where we retrieve some state from the database, we handle the incoming request command, and process that request, and then save the state back to the database, and then the state's gone. So these things, these little dots, kind of appear and grow over time. But the fun stuff, and this is where stateless works really well, is say we get a spike in traffic. I'm going to kind of simulate that here where, say, bam, the traffic's gone up. We got a lot more activity going on. Well, the beauty of stateless is that you can easily scale it. So here I'm showing, instead of running everything on one node, by design, you can easily scale the processing across multiple nodes, like multiple web servers or multiple backends or multiple VMs, cloud servers. Or many of us are moving to Kubernetes, so multiple pods in Kubernetes, so you can easily scale, the system. So this is one of the really great features of stateless, and why stateless is such a common thing to do. So I wanted to walk through a stateless processing flow, just to show a little bit of the mechanics and just kind of put things in perspective. So what I'm showing here in this diagram is that there's a database, and I'm calling this cold state. So the state is kind of frozen and unchanging in the database typically. And then there's the compute side, where let's say the web server, the backend system that's handling the request, and I'm calling that hot state. This is where you pull, you get state, you get it in memory, and you run your computations, your business logic against it, and you make changes. So, the flow is very straightforward, right? A request comes in, that triggers retrieval of the state from the database. Now the state's in memory. I'm kind of representing state in this little green ball. So now we can process the command, the incoming command from the request, and alter the state. And then we, the state changes are saved back to the database, and the cycle repeats where the state's gone. We basically throw away the state. And again, this is by design, because any request to change the state of a given thing, like a given shopping cart or a given IoT device or inventory in a warehouse or whatever your system's doing, any request to change that state could come into any server. So that there's because of this kind of round robin distribution of requests, that we can't, we're sessionless. We don't keep any state information other than while we're actually processing it. So the sequence of, repeats again. If say this a request came in, say this is a shopping cart. The last cycle was add an item to the shopping cart. This one's adding a second item to the shopping cart. So request comes in, we process the command, and read the state, process the command. Jumped ahead here, and write it back to the database, and then send back the response, and then throw the state away again. So that's kind of the cycle. But with a stateful flow, the sequence is a little different. So it starts out the same, where there's no state, say hot state in memory, because systems start up and shut down, and that type of thing. But in any case, say a request comes in a stateful processing flow, just like with a stateless processing flow. This triggers the retrieval of state from the database, from cold state. Now it's hot. We process the command, and then we write the change back to the database, but then send back the response. But this is where things change, because here what happens is that the state's not discarded, because if another request comes in to change that state, the trick is that the system that's handling this needs to be able to route the incoming request to the state, regardless of where it is in a distributed system. And when you can solve that problem, then you can go from a stateless system that can't do this to a stateful system that can. So the idea is that now that the state's already in memory, another request comes in, we don't have to retrieve the state from the database. We just perform the operation against the state. Of course, write the changes back to the database and send back the response. But we're in this loop now where the state's hot in memory. So the next request, it's still in memory. The next request comes in to say, add that second item to the shopping cart. It's already there. We don't need to read it again and write the changes back to a database, which is a great natural for an event sourcing system where, say, the event is add item to cart. So we're just inserting items into an event journal, right? That's the only flow here. We're not reading, constantly rereading the state from the database. So this is the flow. The difference being that the state remains in memory. And another characteristic of a stateful system is that the state remains in memory as long as it's active. If it's not active, then the stateful system should be able to shed the state from memory, just to free up resources and not unnecessarily use resources when they're not active. So this is the kind of the difference between stateless and stateful. The big savings, I think, one of the big savings is that we're reducing the IOs, the inputs, basically. We're reducing those reads of state on every single request. And the approach is done using a single writer, meaning that you can think of the stateful thing while it's in memory as like a stateful object. And all the requests to alter the state of that stateful object are always routed to that object. And there's only one instance of that state, that object, anywhere in a distributed system. That's a tricky thing to do, but it is a solvable problem. The result is that there's kind of this inversion of state, meaning that the state changes are not being handled in memory, and the database is just kind of a secondary storage of the state. where the stateless system, contention is being delegated to the database, through locking, optimistic locking, whatever types of approach. But the idea is that the master of the state is in the database in the stateless system. The master of the state is in memory in a stateful system. So there's kind of this inversion of state. And I remember when I first was introduced to this, when I first started using, really this is a feature of Akka, that it was one of those epiphany moments for me as a developer and an architect. And I finally kind of realized, wow, this is kind of an interesting dynamic that I'm not used to, because I spent so much time doing stateless types of applications in the past. Because there's only one instance, this is also a form of concurrency control. So say this was, this stateless object is maybe like an inventory object, and it's keeping account of the number of products that are in a warehouse or something. And you don't want to give out, accept a sale for a product that's no longer in the warehouse. Say that's a business rule. Well, in order to do that in a stateless system, you have to really depend on locking at the database level. In a stateful system, it's quite a natural thing that once every single command, every single request to say, take another item off the shelf in the warehouse comes to the same object. So when that count goes to 0, that stateful object then can say, nope, I have no more to give out. Any commands that comes in after all the items have been exhausted from the warehouse, are rejected by the stateful object. So enough of that. I wanted to show you a little bit of what's called Akka Serverless, and the idea here is that this is it's in beta right now. It's brand new. It's going to be generally available. This plan is next month in November 2021. But right now it's it's a free beta. Anybody can try it. And the console, there's a console in the CLI, like most things like this. So it's console.akkaserverless.com. And one of the links off of this is the documentation, and I want to take you to the documentation. Now, historically, if any of you are familiar with Akka, Akka has been just Java or Scala, but this is Akka Serverless, so it's polyglot. So right now, the supported languages are Java and Scala, JavaScript, and then there's a bunch of other languages that are also supported, but it's supported by the community. So it's very polyglot. So so things like Python and other languages are coming online where people are adding more support for it. But I'm going to show you a Java example. So in the development tools, if you're a Java developer, you're probably familiar with Maven, and Maven is a tool for building your application. So there's this thing called a Maven archetype, and this will create a project for you, a project directory. So you can come to this command in the documentation, get a copy of it, and then go to CLI and just do a Maven, create run this archetype, and it asks for a few questions that should come up here in a moment. So oh man, so nervous from the late joining. The version. So it just generates a project. And if we go into this project, do a tree on this project, there's not much in it. There's a POM XML. So again, if you're familiar with Maven, this is the definition of how to build your application. There's a README. But the other thing that's in here are some proto files. So these proto files, these are Google Protobuf files. So these are, the idea with Akka Serverless is that it's API first. So the development approach is that you define your API, using these Google Protobufs, which are pretty simple. I mean, I never saw them before I started using Akka Serverless myself. And you define your APIs and you define some other things, but then these protobufs are used to do some code generation. So whenever you do a compile, it's going to generate some code. Now, typically, these are just some sample proto files that came with the archetype. But what I did was I created this project, and I got rid of those proto files, and I put in my own protobuf files. So here's an example protobuf file. It's it's pretty easy. The syntax is not too hard, but what you're defining are things like messages, so like add line item. This is for a shopping cart demo. Change line item, remove a line item. Check out, change the get the shopping cart. That type of thing. And then there's I'm defining a line item object, and I'm defining a cart object that contains a repeated list of line items. So that's it. And then what you do is you define the API. So you define the service, and you define these remote. They're called remote procedure calls. You're just basically defining the API. Now the reason for doing this is a lot of stuff gets generated from this that and is used by Akka Serverless, so that you don't have to write a lot of code. You just kind of focus on the code that you need. So again, like I said, when you compile, you get code generated. So there's two places where code is generated. In a Java project, there's a source directory, which is where your source is at, where you and I would write our own source code. But there's also a target directory. So there's the generators generate source code in both the source directory and the target directory. The difference is that the source code in the source directory is only generated once, because it's intended to be kind of a template for you that that you can see this comment: this code was generated by Akka Serverless tooling. That the file exists, it won't be regenerated. So it's kind of a template driven by the protobuf files that define what the service looks like. So this service is set up now as an event-sourced service that it has this API defined, where these methods will be invoked whenever commands come in, either via RESTful HTTP or gRPC, either one. The protocols are both supported, and these methods will be implemented. So all we have to do is write the code in these methods, add our business logic to these methods and deploy this, and the code's ready to go. So what I did was I ran that Maven archetype. I took the project and I just brought it into Visual Studio Code, and I just made a few changes. One change I made was adding some code here to this empty state, which is kind of just defining what the state of my shopping cart looks like when it's empty. And because the generated code it was throwing an exception. And then I'm just going to leave these. I left these other methods with just kind of these default error messages. The checkout cart is not implemented yet type of thing. So then what you can do is you just do a Maven package, which will the POM file is already set up to create a Docker image, and I've already done that. And then you just you just tag it. It's like any other type of Docker activity, and then push it to a repo. And I'm just pushing it to Docker.io. And then there's some Akka Serverless commands for deploying. You can do it through the console, or you can do it from the CLI. So there's this Akka Serverless CLI. And I'm doing a service deploy. I'm giving it a name, and I'm referencing the Docker image. So I did that command. I'm not going to execute these commands just for the sake of saving some time. And then there's one other command to expose the service. And what this does is it gives the service a host name, and it opens it up to the network. And there's this enable cross-origin resource sharing type setting as well. So that's really the deployment process. That's all it takes. So I did that. And if I go to the console, I have a project already set up, already registered as a user. And in my dashboard, I've got these 3 services already deployed. So here's my demo shopping cart service. And if I click into that, it gives me a bunch of information like what image was, like this shopping cart version 2 tag image was deployed. And it gives me the host name that was exposed. When I did the expose, it gives me a host name. This is running in Google. But another cool thing it gives me is all my APIs are here as well. So like for adding an item, if I click on it, it's a handy little thing. It gives me the grp curl command, which is kind of nice, or a curl command for adding an item to a cart or those types of things. So I can very quickly generate a project, write some proto files, deploy it without making very much changes, and start testing it out. Now there is also running it locally, and there's unit tests and things like that. But the idea is that you can really very quickly get into an iterative cycle, because that's kind of what we'd like to do with serverless. So all the APIs are defined here, and but there's a nice thing in Visual Studio Code. I don't know if I've started using it a while back, and I really like it. I'm a longtime Java developer, and VS Code is just marvelous. And one of the reasons it's marvelous is this. It has numerous extensions. There's this one extension called REST Client. And what I did was I took all the curl commands from the console and pasted them into this file that runs with this REST Client extension. And it also has these variables. So like I got the host name and then some some of the field values that I want to test with. So if I want to test this demo service, I can just send a request, and you can see that I get back a response message just saying the command handler for add item is not implemented yet. It's like, okay, my service is deployed, it's working, and I mean, it doesn't have any code in it yet, but it's there. The thing is that like I've been spending like the last couple of years doing a lot of Kubernetes stuff, and Kubernetes is great. It's way better than before that, but setting up a Kubernetes environment, setting everything up, setting up databases, getting everything working, exposing, setting load balancers, and on, secrets and all this stuff. It's a lot of work to get set up and actually finally get your application to respond to like a network, like an HTTP request. And here you can kind of get it done within minutes, which is something I think a lot of us would like. So doing things in a serverless way. Now what I did was I've got another version of this project where I took it further, and I did implement the business logic. So here is the project, and here is my implementation of my event source entity for my shopping cart. And here now I've taken it where I've got commands coming in, and this is my own style, because now I'm in my code, right? I can do what I want in my code. I just have to be able to take this, implement this add item method and return the response that it's expecting to be returned. So what I did was I just kind of have this pattern here where it's like I said, reject, and I'm passing in the current state and the command. So this is the stateful part of it. The state is being given to me by Akka Serverless, basically. I don't have to retrieve it from the database. I don't know what database it's in. I don't know. I don't care. So Akka Serverless is databaseless. And this reject method, all it does is it just does some basic validation. I'm just trying to show some validation, but I'm using a Java optional. If you're a Java developer, you're probably very familiar with optionals. But the idea is that the reject just does a, if it's a not a valid request, it's going to it's going to reject it, and it's going to return a reject response, or else it's going to handle the request. So in the handle method, this is where I'm taking in the command, and I'm building an event. So, I won't kind of bore you with the details, but basically I'm creating an event, because commands are requests to do something that hasn't happened yet. Commands or events are statements of things that have already occurred. So I'm creating an event, and then I'm in this line here, it's emit an event. And what this is just, this will persist the event into some database. This is all I have to do for the database. If there's no connection, there's no connection pools, there's no sign-in, there's no URLs, there's nothing. The database part of this is being handled by Akka Serverless. So this is basically the pattern, the flow here. And so it's quite simple. And even like with a kind of an event sourced entity, I got into a pretty routine, kind of repetitive rhythm in the code. Every single command, I just do this reject to validate the command given the current state, or else handle the command. And again, this is just my style. And I'll probably change this in the future, but I kind of like it right now. And then the other thing is there's event handlers. So after the event is persisted, this is when I can change the state. So in this event handler, I just had some kind of convenience classes for, after the event has been persisted to the database, I do this handle method again, which actually does these kind of the state changes in memory for me, and that's it. So that's kind of the approach. So in this class, if I run tests, and just for the sake of time, I'll show you that I've already created some stuff. Oh, let me do it with the other one. Not this one. Oh, I know what I need to change. It's customer one. So if I do a get, hopefully I'll get some data. There we go. So I've previously did an add item, and I've just pulled some data from the database. The other thing I did, and I've got a few minutes to show you this, is there's also Cqrs, command query responsibility segregation. So I'm taking the events from the event journal and I'm projecting them into queryable views, and I'll show you the mechanics of that in just a minute. But I'm going to do a query against that view, and here what the view is setting up to show all orders for a given customer. So I've only created one order, and the order only has one item in it. I could, I'll just for fun add another item to the cart. And so I'll run the add item. Comes back with an empty response. If I do a get, now there's two items in the cart, and if I do query the view, it shows the two items in the cart for that one customer order. So views are, or the Cqrs part is also the first defined with a Protobuf, and the Protobuf has a bunch of methods for handling the events coming in, so you can take each event and project it into the view. But the thing I wanted to show you is not this. I want to show you the Protobuf. Sorry. In the Protobuf, you actually define the select. So it's a SQL-like select. So I'm saying select as orders from the view, which I just named as this cart ESE, event source entity, where customer ID equals customer ID. And my view is just structured as cart objects, basically. So I'm just putting the fully populated cart into my view, including the customer ID, so that I can query it by customer ID. So when I do this, the view gets generated for me. So this is all I have to do. No database, no tables to set up, nothing like that. I just define this Protobuf file, and then another class gets generated for handling events. So as events are being created in the journal, the events are being passed to this event handler class, and they're being pushed into the view. So it's basically, like I said, event sourcing in Cqrs using the in a serverless way. Let me just wrap up. I'm going through this really fast, but so this demo app, I just showed you the event source entity and then the view, but actually there's more code in here. And I was showing that you can do things like, and this is all done using Akka Serverless, where I've defined a kind of a simulated publisher of messages to a topic. And this is running in Google again, so it's using Google Pub Sub, but there's this thing called an action that has a API where I can run a test where I can add, invoke the HTTP endpoint for add an item to a shopping cart. That code is going to run, and it's going to push something into a topic, and then and that's in one service. In another service that I've deployed that I was just showing you, there's also this thing that can consume those messages from the topic, transform them into messages that can be forwarded to the event source entity, and then they get written, and then using basically Cqrs, the data is pushed into a view. There's a parallel flow here where it's functionally equivalent. The APIs are the same. It's a different topic, but it's called a value entity, and this is CRUD. So instead of event sourcing, we are doing a CRUD-like operation. So we're only saving the state. We're not saving in events. We're not persisting the events. We're just persisting every time something, the shopping cart changes, for example, it's being persisted to the database, but they're still Cqrs. So those changes to the shopping cart are still projected into a queryable view that provides the same kind of a query, select customers by, or select orders by customer ID. So that's kind of the flow here. Just wrapping up, these are the two projects. My Twitter handle is McKee H3. So if you want this, and I'll publish these slides, but if you're looking for these GitHub repos, just look for McKee H3, and it's shopping cart Java Akka Serverless, and the pub sub one, the publisher on the pub sub side is shopping cart pub Java Akka Serverless. Just McKee H3 in GitHub. So sorry again, I was late. I was freaking out trying to get logged in. But really thank you for your time. I hope somebody is out there listening to this. And if you're interested, check out Akka Serverless. Like I say, it's free to try right now. And serverless itself is like super low cost anyways, even if it is a cost, because you can always just scale it back to zero pretty easily. But you can start at lightbend.com and just do Akka-serverless, or you can just go to console.akkaserverless.com. And if there's anybody around, I'm available for questions.